Assalamu alaikum guys. Now we are going to discuss the quiz number 40 under revision quiz session. So let's start the quiz number 1. The decreasing order of radii of the species. Oxygen, oxygen 2 minus, fluorine, fluorine minus, sulfide ion is 2 minus, and fluoride ion. So you have to write the decreasing order of the radii. So this is for that. This is a kind of the ionic radii and the atomic radii concept. We have studied the end of session of the unit 1. This is always in your MCQ. Definitely you will based on ask the question based on this theory. So let's see do the question. Okay. So when you speaks about the atomic radii, always your anionic radii, anion radii, always higher than the parent, right? Parental. As well as when you speak about the cation radii, is less than your parent atomic radii. This is the concept. According to that, you have oxygen, oxygen 2 minus, fluorine, fluorine minus, fluorine is 2 minus. Okay. So this is very important. You should be able to understand. So here the anions will have highest atomic radii. The size is big. So let's take the anion first and we will talk about that. O2 minus, F minus, Cl minus is 2 minus. The first thing is you have to check the number of shell. If the number of shell increases, the atomic radii, yes. As the number of shell increases, the atomic radii will be increased. So what do you want to do is, first we will write the number of shell. Oxygen, second period. Fluorine, second period. Fluorine, third. Sulfur, third. Now you have to check here the number of shell is same. So if your number of shell is same, you have to go for what? Next, the proton number. As the proton number increases, the ionic radii will decrease. Why? The number of proton increase, the electron shielding effects will be increased. Therefore, your atom will become small. So your ionic radii will decrease. According to that, take your O2 minus and the fluorine, F minus, right? What is the proton number for oxygen? 8. What is the proton number? Oxygen is 8. What is the proton number fluorine? It's a 9. So according to that, okay, no need to, sorry. Okay, we'll write 8, 9. According to that, which is the bigger one? O2 minus or fluorine. Highest the proton number, the ionic radii will be decreased. Therefore, your fluorine is a small one, O2 minus. Is it clear? Right, I found that area. And we'll take another color. Okay, when you take the chlorine and sulfide, Again, that is 3, 3. Let's rewrite the proton number. Yes, your chlorine is a 17, your sulfur is a 16. Now again, the number of proton number increases, the ionic radii will be decreased. And you know, as the number of shell increases, the ionic radii increases. So according to that, your chlorine having 17, your sulfur having what? 16. So which is having the least number? Your chlorine. So this is Cl minus and your 16 is sulfur. Is it clear? Is it clear? So the first thing is you have to go for the number of shell. As the number of shell, the atomic radii will be increased. So you know either, so I can write here either oxygen, fluorine, okay, O2 minus, F minus, and you know which is always bigger than, smaller than the Cl minus and S2 minus. I have found first this, right? Okay. Second, I have checked, right? The proton number, according to the proton number, the oxygen is 8, the fluorine is 9. Highest the proton number, the ionic number will be decreased. Therefore, F minus, this is O2 minus. Why? It is having 8, so 9, this is 8. So this is what? As well as we know your chlorine and sulfide, when you take your chlorine is a 17, your sulfur is 16, right? As the ionic number, proton number increase, the ionic number, ionic radii will be decreased. That means what? Your Cl minus is less than the S2 minus. Now, we know definitely this is 2 shell ion. This is 3 shell ion. So it is always bigger than this. I have found the order of ions. Now, let's take the oxygen and fluorine. Seems to be applied the same set of the rules and you can find the answer. So now I'll erase this part. Okay. So we have found the answer. I'm keeping like this. Okay, so again, here you have now oxygen and fluorine. Apply the number of shell. Again, this is 2, 2. And go for the proton number. This is 8, 9. So number of atoms, number of proton is increases. The ionic number will be decreased. So you know the oxygen is higher than the fluorine. So let's rewrite the decreasing order. So you can say your fluorine is less than the oxygen. Now, and we already said the anion is less than the neutral atom. Sorry, the size of the anion. So here I can show that words. Anion will have the highest radii. So you can say what is there. Size of the anion higher than the neutral atom. So therefore, so this is what the decreasing order. First we will write according to that the increasing order. The F will become first, then oxygen, again F minus, O2 minus, Cl minus, S2 minus. I wrote the increasing order. So let's go to the question now. According to this, we have found the answer. Right, we have found the answer, right? So increasing order, I say the number of atomic number increases, the ionic radii or atomic radii will decrease. So let's rewrite the increase order first. increase order first. So what should be that? It is the F fluorine, oxygen, F minus, O2 minus, Cl minus, S2 minus. Shall we write the decreasing order now? S2 minus, Cl minus, O2 minus, F minus, oxygen, fluorine. So this is your answer. So according to that, you can conclude your answer is S2Cl O2 F minus FO. So your answer is number 2. I'm sorry, oxygen fluorine. Your answer is number 1. Okay, the answer is number 1. So we have done the question number 1. Let's move on to the question number 2. A rigid closed container contains the N1 moles of an ideal gas at temperature T1 Kelvin and pressure P1 Pascal. When an additional amount of the gas was inserted to a container, the new temperature and the pressure were T2 and P2 respectively. The total number of moles of the gas now in the container. So let's write it. So this seems to be what the ideal gas equation. By using that, you can say initially your that isolated one, it's having what? The rigid container having what? N1 mole of the gases, ideal gas with T1 temperature, P1 pressure. When you insert the gas, okay, after that, the volume is the rigid container same, the volume is constant. So again, you are getting what? Now you are having the pressure is N2 gas, or you can say N total, whatever, but the temperature at T2 and P2. So you have to find what is the total number of mole present in the after insert of the other gas. So let's write, when we speak about the ideal gas, first you're able to write the equation that is PV is equals to nRT. By using that, apply for this. This is what? A container, B container. So insert for A, container A. So P1, V is V, N1, R, T1. So this is equation 1. For container B, right? P2, V, N2, R, T2. Right? Now you have to get the N2 answer. So divide 2 equation by 1. So you can write this is what? P2V divided by P1V, which is equals to N2R T2. It's equals to N1R T1. So RR will cut off, VV will cut off. So N2 is equals to P2 N1 T1, which is divided by P1. Sorry. P1 into T2. So let's move on to the question. So according to that, we'll raise this up. Okay. Your answer is okay. N2 is equals to P2 N1 T1. Where is P2 N1 T1 divided by T2 P1? Your answer is number 2. So if you want to rearrange it, I write in the rearrangement method. So N1 T1 P2 divided by P1 T2. So this is the answer for question number 2. Let's move on to the question number 3. We'll go for the question number 3. The total number of electrons exchanged in the reaction of the oxidation of ethanol to acetic acid using acidic chromate solution. So this is what the usual equation they have said about what they are speaking about the redox reaction. So let's say write the answer side. Okay, then I don't want to come back. I will show you. This is a MCQ, so don't waste your time. Let's say find the answer quickly, right? To reach the answer. So your answer number 1 is 6, 2 is 8, 3 is 10, 4 is 12, 5 is 40. Okay, let's say go for explanation of this question. Okay, so what is happening here? They say your ethanol is converted into acetic acid. Let's write the compound of the ethanol. So that is C6H5OH. Not C6, C2, sorry. C2H5OH, right? C2H5OH, 2, CH3COOH. So you can write, so by keeping this, you have to find the oxidation number. So you can write in this manner, this should be easy, COH, H, CH3, right? Okay, and which will give COOH, CH3, right? And next, your dichromate ions, Cr2O7 2- will give Cr3+. You have to balance the equation, that is 2. Now we'll do the question. So first we have to find the oxidation number. You can see the carbon, which is having what? The -1. Here, this is +1, +1, and this is 0. So carbon, X is equal to X plus 2 plus -1. Your answer is X plus 1 is equals to 0. So therefore, your X is equals to -1. This carbon charge is -1, right? And check here. This is -2, 0, -1. Okay, so what is happening? X plus -2 plus -1, which is equals to 0. So X is equals to +3. So here charge is +3. So oxidation number is +3. Now let's rebalance the electrons now. So here it's a -1 +3. To make it a balance, I am adding 4 electrons here. 4 electron means what? This is reduced and extra 1, thus both sides the oxidation number now -1. I have balanced the equation. No need to add the water and everything. Your question is they are asking what? The number of electrons. Again, you can check here. What is the oxidation number? The chromate ion. You are very familiar with that. That is the answer is for the chromate. One chromate is the 6 minus 6 for 2. You have to find minus 12 charge. Here 3 plus 2 into 3 plus 6 plus. Sorry, plus 6 plus 2. So according to that, you have to balance the equation. Here 6 plus 6 or 12 plus. You have to add plus 6 electron here. Then you will balance the oxidation state here and there. Right? Okay. So what is the total number of electron change? Obviously, most of you all will know the 6 and 4. Your answer is number 3. That is wrong. You have to write the balanced equation. Then only you have to speak about what is the answer. So first, right? Okay. So we have to write the answer. Before that, here 6 electron, here 4 electron, right? So according to that, that is 1:1 ratio, this area. So we will make it as very smallest ratio. So when you take the C2H5OH is to K2Cr2O7, right? Your electron ratio is 4:6. So you can reduce, that is 2:3. Take it as a small. Now you can multiply this equation 1, 2. Then you can, this is, I said, you can convert this is as a 2, this is as a 3. Now you can interchange the answer. 2 chromate ions, CrO2 minus plus 3 C2H5OH. So now can you say, you have to go for the balanced equation. Now you can say your chromate having what? 3 electron. So 2 into 3 electron plus 3 into 2 electron. So your answer is 6 plus 6, 12 electrons. So though you did not take the smallest ratio, what will be happen? You will get the answer here. Yes, 4Cr2O7 2 minus plus 6C2H5OH. So what should be the answer here is 4 into 3 electron plus 6 into 2 electron. So you will end up with 12 plus 12, 24 electron. There is no answer like 24 electron. That's why I took the smallest ratio. So you have answered 12. The answer is there. So this is the correct answer. So no need to balance the water. No need. So first you have to find what? The oxidation state. Interchange of the electron, take the least one. If you keep like that, there is no highest number of electron. That's why I go for the least ratio, very smallest ratio. From that, you have to write the balanced reaction first. Without writing the balanced reaction, just adding the 6 and 4, giving the 10, that is wrong. Once you write the balanced reaction, you will get the answer is 12 electron. This is very, very important. Let's move on to the next question. Which compound of the following can undergo aldol condensation when react with aqueous? So the aldol condensation is a very common reaction that we have studied in organic chemistry. So aldol means what? You will have the another side of this and the same condensation, you will get the answer. Here the question is missing. Give me a second. Okay, let's go move to the question number 4. So, which of the following can undergo the aldol condensation when reacted with aqueous anions? So, you have to find that which is able to go for the aldol condensation. The one thing is your answer should be aldehyde and ketone, which is able to undergo for the aldol condensation. Here, this is what except this is carboxylic acid. The first others are aldehyde and ketone. So, you can omit answer number 1. So 2, 3, 4, 5. According to that, we are going to speak about the self-condensation reaction. If the strong electron withdrawing group because of this carbonyl group, right? The hydrogen atom, the next to the carbon, there should be a hydrogen atom. The strong carbonyl group which is attached to that carbon should be the which is able to contain that carbon we are calling. Wait, I will go and show you. This is your strong electron withdrawing group, which is attached to the next carbon we are talking. This is the alpha carbon that is attached to the hydrogen we are talking. That is the alpha hydrogen that is able to undergo for what? The self-condensation reaction. Why? These alpha hydrogen become more acidic, which is able to attract towards the sodium hydroxide OH minus. Right? Okay, then it will become as a carbanion ion, right? For the stabilization, this carbanion ion again react with the same group, right? Now it will perform the condensation itself. So this is what is happening here. So you have to speak here what alpha hydrogen, alpha carbon. So let's check. The carbon should have the alpha hydrogen and alpha carbon. Self-condensation. The oxygen is there, so this is not possible. This is not possible. And you can see here the carbon is there and this carbon, okay, and here also next carbon, the alpha hydrogen carbon is possible. The alpha carbon is possible. What about the alpha hydrogen? When you take this group, right? When you take this group, right? I will write here, outside your COH, you will have this carbon with CH3, CH3, CH3. This carbon does not have alpha hydrogen, no alpha hydrogen. Therefore, you can omit the answer 5. So your answer is number 4. We are talking about quickly you can find the answer. Your answer is number 4, which is able to form the alpha carbon along with the alpha hydrogen, which is taking part in your reaction. That is what you can speak about. This is the alpha hydrogen. Let's write the condensation reaction for this. So your answer is number 4. Okay, so what is happening here? 2 CH3, CH2, COH. In presence of sodium hydroxide, you will end up the answer is CH3, CH2, right? You have 2, right? It will become as OH, right? The hydrogen is here. Okay, again, this hydrogen. The next group will combine carbon, again, this CH, okay? the CH, CO, CH, CO, H, it will have the CH3. Did you understand? So here, the first step, this is become as a OH, and next step, this is become as a minus. That minus, one hydrogen removed, that minus will combine with this, and you will get the rest of the structure. So this is what will undergo for the aldol reaction. And let's we move on to the final question of this quiz number 5. So seems to be here we are talking about the solubility product AX solid, A2Y, AZ are sparingly soluble salts in the water having the KSP are given. The respectively at 25 degrees Celsius. Which of the following shows the order of the saturated solution of these salts in decreasing concentration of A plus? So we are going to speak about the decreasing concentration of the A plus. So before that, I better to write and keep this value this side. That should be easy for me. Okay. Your AX is equals to 1.6 10 to the power of minus 9. A2Y is equals to 3.2 10 to the power of minus 11. AZ equals to 9.0 10 to the power of minus 12. Okay, minus 2. Fine. The order of the answer I will write here. Okay, right. This is enough. Let's redo the question now. So according to that, we have spoke about the sparingly soluble salt, KSP. So here we are talking about the KSP values. So first we write the equation for the sparingly soluble salt. Give me a second. Right, according to that, the saturation solution of the concentration, decreasing order of the concentration should be fine. So first we will write the equation. The AX solid, sparingly soluble, so reversible reaction. A plus, sorry, X plus. This is aqueous, this is also aqueous. So let's rewrite the solubility. So when you write the solubility, right, if you say this is X and this is also X, this is also X. So let's rewrite the KSP value for X. So this is what past paper question, sorry, MCQ question, you have to do very fastly. So KSP of X. So you can write, this is as a concentration of A plus aqueous. No need to write this thing for your work. I'm just showing how to do this one. X plus, so that means what? X squared. So you know the KSP value is given, that is 1.6 into 10 to the power of 9. You can write it as a 16 into 10 to the power of 10 minus 10, which is equals to X squared. So your X is equals to 4 into 10 to the power of minus 5 mole decimeter minus 3. Likewise. I'm going to write for the next reaction. A2Y, which is giving A plus y, 2 minus 2a plus. This is solid, this is aqueous. When you speak about what the solubility product, if you say this is x, this is 2x, this is x. So the KSP of this is, okay, so your answer is 2x power of 2 into 2x. So value your answer of the KSP of A2y is equals to 4x cubed. Is equals to 4x cubed. And now you can substitute this is as what? 3.2 10 to the power of minus 2. You can write 32 into 10 to the power of minus 12, which is equals to 4x cubed. So if you cut off this answer, you will have the 8 into 10 to the power of minus 12 x cubed. So x is equals to 2 to the power of 3, which is divided by 3, that 2 into 10 to the power of minus 4. This is for what? X1. And you can write for what? AZ, that is 9 into 10 to, so I will raise this. And I can utilize this area, then I can write in one shot to explain you all. Right. So the next reaction is AZ, which is given A plus Z minus. This is aqueous, this is aqueous. And this is what? Sorry. And here again the solubility, if it is x, this is x, this is also x. So your KSP is equals to x squared, right? So the value is given 9 into 9.0 10 to the power of minus 12, which is equals to x squared. So your answer is x is equals to 3 into 10 to the power of minus 6. This is also mole decimeter minus 3, mole decimeter minus 3. You need the concentration of A. I have found X. So what is the concentration of A here? Okay. The concentration of A here is A plus 4 into 10 to the power of minus 5 mole decimeter minus 3. Here concentration of A. That is what? 2x squared, right? Sorry, 2x, right? So what do you want to write this? 4 into 10 to the power of 4 mole decimeter minus 3. And concentration of A here. Three into 10 to the power of minus 6 mole decimeter minus 3. And decreasing order. Yes. What is that? Your AZ is having 10 to the power of minus 6. So that is what the least value. So AZ is very small, having 3 into 10 to the power of minus 6. Next, 4 into 10 to the power of minus 5. AX. Then A2Y is a big one. So let's say write the value here. Oops, sorry. So AZ is, what is the answer? 3 into 10 to the power of minus 6. This is 4 into 10 to the power of minus 5. 4 into 10 to the power of minus 4. So this is your value. According to that, you can perform the answer. So your question answer is Okay. According to that, your answer is that should come first. So that is what you have to write, decreasing concentration, right? So decreasing concentration means highest one should have first A2Y, the least one should. So your answer is number 2. Decreasing order, your A2Y, A, Z. So we have found the answer. A2Y is, what is the value for A2Y? 4 into 10 to the power of minus 4. AX is 4 into 10 to the power of minus 5. AZ is 3 into 10 to the power of minus 6. So according to that, I have select answer number 2. So this is what seems to be very, very easiest question, your 2020 paper. I just want to do the first 10 question, which is easily score, and you can gain the marks. Okay, guys. Okay, inshallah. Next, we will meet with the next set of the 10 question with next week. Until that, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh. Take care, guys. Thank you very much for your kind cooperation. Bye. Salam alaikum.